Homework 2, question 19, the second of the challenging questions. So this is a bit messier of an equation. Let's see what we can do with it. But again, the principles stand. The first thing I'm going to do is I'm going to do a little bit of algebra to see if I can get this in the form of ax to the power of n, as much as possible. So looking at this, I have y is equal to, now in the numerator I have 9 over x. I can rewrite that as 9x to the power of negative 1. Plus 4 over x squared. I can rewrite that as 4x to the power of negative 2. In the denominator, I have the root of x, the square root or the second root. So for the root, I'm going to write x to the power of half. And then I have plus 7. So that's my first step. Now I'm going to try to simplify this further. I can rewrite this as 9x to the power of negative 1. Now, because I have a shared denominator separated by a plus, I'm going to rewrite it like this, but I'm going to separate these into two fractions, both with x to the power of half as the denominator. Now I'm going to use the rule x to the power of a over x to the power of b is equal to x to the power of a minus b. That's in our pre-calculus formula sheet. So here I have 9x to the power of, well, I have negative 1 as an exponent minus half. So negative 1 minus half plus 4. Here I have common bases in my fraction as well. So I'm going to have x to the power of negative 2 minus half. And then plus 7. Now doing my fraction math here, I have negative 1 minus half. So that's really negative 2 over 2. That's the same thing as negative 1 minus half. That gives me negative 3 halves. And over here for this exponent, I can combine those. Negative 2, I want the denominator of 2. So that's going to be multiplying both the numerator and the denominator by 2. So I have negative 4 halves minus half. And that's going to give me a total of negative 5 halves. So rewriting my expression now that I've done my fraction math there, excuse me, I'll put this back in blue. I have 9x to the power of negative 3 halves plus 4x to the power of negative 5 halves plus 7. Okay, so this is my y expression. No calculus done so far, or no derivatives, I should say, done so far. Now I'm going to do my first derivative using the power rule. So dy by dx. For those that want a reminder of what the power rule is, it's when y is equal to ax to the power of n, dy by dx is equal to anx to the power of n minus 1. And I'll just change the color of that for a moment so it doesn't get confused with the rest of our work. Now doing the derivative, I'm going to first focus on our term 9x to the power of negative 3 halves. The 9 is a coefficient, it just goes along for the ride. And then I pull back the exponent, negative 3 halves. X to the power of negative 3 halves minus 1. 1 is the same thing as 2 halves. Plus, now for our next term, I have 4x to the power of negative 5 halves. So the 4 is the coefficient, it just goes along for the ride. I pull back my exponent, negative 5 halves, x to the power of negative 5 halves minus 1, which can also be written as 2 halves. And finally, I have the derivative of 7. It's the constant rule that I'll use here. The derivative of a constant is 0, which I don't even have to write. Now cleaning this up a little bit, I've got to do my multiplication here. 9 is the same thing as 9 over 1. So I have 9 times negative 3 is negative 27 over 2, x to the power of negative 3 halves minus 2 halves. I add up those numerators and I get negative 5 halves. And then here I've got what's essentially 4 over 1, so I multiply 4 times negative 5 for my numerators. That gives me minus 20 over 2 times 1 is 2. X to the power of negative 5 halves minus 2 halves gives me a total of negative 7 halves. I could clean this up a little bit further and go negative 27 over 2, x to the power of negative 5 halves, minus 10, because 20 divided by 2 is 10, x to the power of negative 7 halves. And that is my first derivative. Now for the second derivative, I'm going to do the derivative of the first derivative. So I'm going to focus on this first term first. Again, using my power rule, the coefficient negative 27 over 2 just goes along for the ride. Then I pull back that exponent, negative 5 halves, x to the power of negative 5 halves minus 1, which can also be written as 2 halves. Now I'm going to focus on the next term, which is negative 10 x to the power of negative 7 halves. So I have negative 10, which is my coefficient. It just goes along for the ride. Then I pull back that exponent, negative 7 halves, x to the power of negative 7 halves minus 1, which can also be written as 2 halves. Cleaning this up, I'm going to multiply my numerators. Negative 27 times negative 5 gives me positive 135. Also have to multiply my denominators over 4. X to the power of, now I'm going to add these fractions, negative 5 halves minus 2 halves. I have negative 7 halves. And over here I'm going to simplify this fraction. First, 10 gets divided by 2 to give me 5. And then I have negative 5 times negative 7, or plus 35. X to the power of negative 7 halves minus 2 halves gives me negative 9 halves. And that is my second derivative.